start with electronic configuration. Electrons in an atom, they fill out in their order. So I'm going to write that order of filling electrons. Let's say n equals 1. Let me rewrite that. N equals 1. Level n equals 1. We have 1s sublevel. N equals 2, we have 2s and 2p sublevel. N equals 3, we have 3s, 3p and 3d sublevel. N equals 4, we have 4s, 4p, 4d and 4f sublevel. Okay. N equals 5, let's say 5s, 5p, 5d and 5f. Now I'm going to show you the method that explains how you can fill it in electrons. So when you see that arrow, that means that's the order of you can fill it in those sublevel. Okay, so let me, alright, so as you go this way you can start filling in. So let's say every orbital fill out 2 electrons. So once electrons go in, they can fill out 2 electrons. Let's say for lithium, when you look at lithium in a periodic table, it has how many electrons? 3 electrons, right? So how do we write electronic configuration for lithium? Lithium, when you write electronic configuration, 1s2. 1s2. Now this sublevel is filled. Now where is the other electron go? So it will go to next level, which is 2s1. So that's the electronic configuration for lithium. Okay, so that means each orbital has a capacity to hold 2 for s level. P level has capacity of 6, D has a 10 and F has a 14. So that's the max capacity of, okay, and you can fill out electrons in this following the arrow. Once you fill out, then go to next one. Once you fill out, then go to next level. Once you fill out, then go to next and next. Alright, so let's start working on writing electronic configuration for, let's say, boron. Boron, when you look at the periodic table, okay, boron has how many electrons? 5 electrons. Alright, now we will start boron. We can write 1s2 because s level contains maximum 2. Once s level fill out, we'll go to next level, which is 2s, right? You see that this level we will fill out. So 1s2 and then 2s2. Now out of 5, 4 is gone. How many left? 1. That one goes to here, next level. Once this is filled out, you go up the arrow and then you can write 3s1. So that's the electronic configuration for boron. Okay, now that's electronic configuration for boron. This is called longhand configuration, but if we want to write shorthand notation. So for shorthand, let's say for boron. Before boron, which one is a noble gas? We say in the periodic table, helium is a noble gas, which has electronic configuration which is 1s2, right? So we can write He and then we can write 2s2 and 3s1. So that's shorthand notation, right? Because helium, noble gas, has a 1s2 configuration. So we can write shorthand notation. This is a longhand notation. And this is the shorthand notation. Now let's practice few more, and then but always follow this diagonal line, these lines, and fill up the electrons. Okay. So now let's start practicing on few of those elements. Now you can see, look at your table, and we have element. We have element zinc. Now when you see in a periodic table, how many electrons in a zinc? Total we have 30 electrons. Now we need to fill up electrons, right? So we can say 1s2, 2s2, 1s2, 2s2, 2p6, because p has maximum capacity 6. So when you count that, 2 plus 2 plus 6, we have 10 electrons. So out of 30, we have 10 gone, so 20 left, right? So 1s2, 2s2, 2p6, then 3s2, 3p6, then what? 1s2, 2s2, 2p6. How do we find? Follow your the diagonal line and tell me what you do. Let's go back. 3p6, then what comes?
3D.
And then 4s, right? So 3d10, so it's 20, right? And then we have, hold on, 3d10, no, not 3d, it's 4s2, sorry. It's going to be 4s2, then 3d10, and let's see, 3d10, okay. So this is 10 electrons, 10 electrons, and 10 electrons, total 30, right? So that's the electronic configuration for zinc. That's the long hand configuration. And then we need to write down for shorthand notation. Now remember, before zinc in a periodic table, which one is a noble gas? Argon. So we can write argon. And then argon has 18 electrons. So we can see 10 and 18. This one is already been indicated as argon. So now what we need to write?
4s2,
4s2 and 3d10. So that is shorthand notation for zinc, right? So that way we can mention for zinc longhand and shorthand.
Ms. Bobna,
Yes.
where on the periodic table would 3D be?
Huh?
For n equals 3, 3D, like we skipped that.